Here we go, section 4.5, complex numbers, and again we'll hopefully have your notes for you by tomorrow. We're going to finish up probably all of chapter 4 today. Section 4.5 short, section 4.6 short, so we'll go through these hopefully and finish up today. The complex number system, it says, is a combination of the real numbers as well as complex numbers. So we've got some numbers outside of the real realm. Complex numbers includes everything. Okay, you've got the real numbers, and like we're going to talk about today, you've also got the imaginary numbers. Is all the complex numbers. The complex number system also includes a number I, such that I is the square root of negative 1. Make sure you know what I stands for. We call this an imaginary number. A complex number, though, just because it's imaginary, that's not the complex. Complex is a combination of the two. A complex number is any combination of real and imaginary numbers of the form a plus bi. Where you have a real part and you have an imaginary part. Here are some examples. 2 plus 3i. That's a complex number. Real part, imaginary part. Negative 2 minus 4i, 6 minus 5i. Those are complex numbers. Every real number and pure imaginary number can also be written as complex numbers. So any number that you've ever seen is a complex number. Such as the number 2. That's complex, even though we said it's real. It's also complex because you can write it as 2 plus 0i's. No imaginaries. The imaginary number negative 7i is also because you can write, okay, there's no real part. 0 minus 7i is complex. So everything that you've ever seen is complex. Find x and y if the two complex numbers are equal. This is easy. All you've got to do here is if these two complex numbers are equal, then the real part equals the real part, the imaginary part equals the imaginary part. So what we're going to do there, you've got 2x plus 7i equals negative 7 plus 3iy. So again, you have a real part and you have an imaginary part. If these two things are equal, then the real parts are equal. So just come down here to find out what x is. 2x must equal what? Negative 7, so x is negative 7 over 2, or 3.5. The imaginary parts are equal. Do you have to include when you're doing this part of it, do you have to include the I? No, because if you know the imaginary parts are equal, you can just say 7 is equal to what? 3y. So y must be 7/3, which, okay, go ahead. The real part equals the real part. Because these are complex numbers, you have a real part and you have an imaginary part. The imaginary part equals the imaginary part. So just set the reals equal to each other. Set the imaginaries equal to each other. Because you know both of them are I stuff. Both of them are imaginary parts. Which if you want to include the I, it's going to divide out anyway. Divide both sides by I, it's going. So 7 equals 3y. Next up, powers of I. Here's something y'all didn't really understand all that well last year. Hopefully we'll get it this time. Keep in mind again the first power of I to the first power. I is the square root of negative 1. I to the second power. We're going to go down through these one at a time. I to the second power means you have I times I, correct? That would be the square root of negative 1 times square root of negative 1. Is everybody okay with that? How do you undo square roots? What's the square root of 3 times the square root of 3? It's 3. The square root of 4 times square root of 4 is 4. So a square root times a square root, it undoes each other. This is a square root of negative 1 squared. Take away the square root, what do you get? The I squared is negative 1. When you square it, it simply removes that square root. Yeah, powers of 4, yeah. We'll do those in a second. I to the third. Okay. I to the third, you've got, if you want to do it like this, you could do, that's the square root of negative 1 times the square root of negative 1 times square root of negative. There's several different ways you can think of this. Square root of negative 1 times square root of negative 1 was negative 1. Times the square root of negative 1, we can't do anything else with that. So if you want to leave it as a square, negative 1 times I is fine, or just negative I. So I to the third power is I squared times another I. which is just negative I. So we got I is the square root of negative 1, I squared is negative 1, I to the third is negative I to the fourth power. If you want to think of it like this, and I didn't do this last year, maybe this will help out. That's the square root of negative 1 times the square root of negative 1 times the square root of negative 1 times the square root of negative 1. These two and these two, what's square root of negative 1 times square root of negative 1? What was negative 1 times negative 1, which is 1. Yes. Yeah, I've got it in your notes again this year. So if you don't want to copy these down, I've got them. So we have, I'm going to erase the explanation. I is the square root of negative 1, I squared is negative 1, I to the third is negative I, and I to the fourth is 1. Now when you get to the bigger powers, I to the fifth, you're going to take some combination of these powers up here. I to the fifth would be, instead of 4 of these, you would have 5 of these. But what was 4 of them? 1. So you have 1 times, what is this equal to? I. So you have 1 times I, which is I. Do you see it starts over? I to the sixth power, you would have 6 of them. So you'd have, all this is 1. Does it make sense? These other 4 really makes no difference. Square root of negative 1, square root of negative 1. These 4 over here is just 1. So all you're concerned about is these. Square root of negative 1 times square root of negative 1 is negative 1. I to the seventh, you've got another one, square root of negative 1. So that's going to be, this was negative 1, this is I. So you have 1, negative 1, and I, which is negative I. I to the eighth power, you've got another one. These 4 was 1, these 4 is 1, so 1 times 1 is 1. So it repeats, it's cyclic. It goes in a cycle, is a word you can use, cyclic. So every 4 powers, like I to the fourth, I to the eighth, I to the 12th, I to the 16th, and I to the 20th, and so on and so forth, will always equal 1. So what you can do is any bigger power, which is what we're going to do next. Let me go to the next problem. Notice that the powers of I start to repeat. We can use this fact to easily find high powers of I, such as I to the 93 and I to the 48th power. I to the 93rd power and I to the 48th power. Let's try to find these two. What I would do, this is my thought process when I do these. I think, okay, all the multiples of 4. 4, 8, 12, 16, 22. Does everybody understand 88 would be a multiple of 4? So what would be the next one after 88? I to the 92nd power would be 1. All the powers of 4 is 1. So what would I to the 93rd power be? It'd be the next one in line would be just I. I to the 48th power, isn't 48 a multiple of 4? So I to the 48th power is 1. I to the 4th, I to the 8th, I to the 12th, I to the 16th, all the multiples of 4 is just plain old 1. Square root of negative 1, always. So what I would do, and especially if you have these on ACTs, I would memorize how to get the first 4. Because if you know the I is the square root of negative 1, I just showed you how to find the other ones. I squared would be 2 of them, I to the third is 3 of them. If you can memorize the first 4, how to get them, then you can find the rest of them. Makes sense. Performing, it says arithmetic of complex operations. These shouldn't be too bad. We did a lot of them last year. Example 3 says perform the indicated operation, and I'm just going to do these right here. If I can get my pencil to come up. First one says 2 plus 3i plus negative 5 minus 7i. When you're doing operations, treat it like a variable. Plus sign, you're adding these two things. Do you need parentheses? No. Combine like terms. 2 and negative 5 is negative 3. 3i minus 7i. That's it. Negative 3 minus 4i. Treat it like an x. You okay with that? Same way with the next one, except for you have a minus. What do you do since we have minus in front of that parentheses? Distribute the minus. Negative 2 plus 5i, finish that up, will be minus 3 minus 4i. And then combine like terms. Negative 2, negative 3, negative 5, 5i minus 4i plus I. And notice again, complex numbers. Add 2 complex numbers, you get another complex number. Subtract 2 complex numbers, you get another complex number. Multiply them, you get a complex number. Divide them, you get a complex number. Yeah, right here you got 3i times, and I'm going to do this on my other sheet. 3i times, because this one's got an extra step, negative 2 minus 4i. Yeah. Distributive property, 3i times both of them. 3i times negative 2 minus 12i squared. We don't like I squares. Don't leave it as I squared, because from our list a while ago, I squared is equal to something. Anytime you have an I squared, that's the same thing as negative 1 from your list. So you have negative 6i minus 12 times negative 1, which is negative 6i plus 12. And if you want to write that in the how these complex numbers are normally written, it's usually real complex, so 12 minus 6i. You can write it either way. Yeah. Yeah, I believe my brains mature a little bit in that 11th and 12th grade. You don't think? I said brains, not people. 3 minus 4i times negative 2 minus 2i, distributive or excuse me, full. That's all this is. 3 times both of them, what do you get? And then negative 4 times both of them. There you go. Combine the middles, you get negative 6 plus 2i. And again, anytime you have an I squared, that's negative 1. Positive 8 times negative 1 would be minus 8. So that's going to be negative 14 plus 2i. And again, it always amazes me. Multiply two complex numbers, get another complex number. It's the same form. That's it. We're done.